And welcome everybody to the Indicio Identity Community Meetup. I'm continuing to let people in to the meeting today, but I just wanted to thank all of you for coming. It's great to see such a good turnout for this conversation. This is a place where we can learn. It's a place of learning. So we're going to have the opportunity today to learn, something about the latest and greatest in advancements, trends, and issues in the decentralized identity and verifiable credentials communities. This is offered as part of Indicio's public benefit mission to accelerate the creation and adoption and widespread use of verifiable credentials for identity. Just a few sort of housekeeping items. We are going to be monitoring the chat during this conversation, so feel free to pop in questions. We'll also have some opportunity for some discussion at the end. So if you don't hear your question answered or you don't feel comfortable, we will have the opportunity to address those at the end there. Also, before I turn it over to our awesome speakers today, we are going to have another event at the end of September, and I believe the conversation will be around FIDO and decentralized identity and how the two complement one another. So if you're interested in that, keep an eye on the meetup page. The meetup page is also a great place to keep the conversation going after this event. So feel free to keep in touch there. So I guess with that said, I'll toss it to Sam Curren and Daniel Hardman. Sam is the senior architect and deputy CTO of Indicio. He's also the co-chair of the DIDComm Working Group at DIF. So we're glad to have Sam, and also thank you so much, Daniel Hardman, who is the CTO at Provenant. And I'm sure there's a number of organizations that he is also a part of in the open source and open standards world as well. So I'll let him introduce himself, but thank you, because you're based in Europe somewhere, right, Daniel?
Yeah, I'm just down the road from Geneva, Switzerland.
Oh, nice. Okay. Well, thank you so much for joining us today. But with that, I'm going to stop sharing and I will pass it along to our wonderful speakers.
Daniel, let me introduce you real quick and then we'll throw it to you. I am grateful to Daniel. I roped him into this. It doesn't say that under in his title on the title screen, but Daniel has been a major supporter and developer of DIDComm since the beginning. Well, there was some convincing early on, and then he was. So, so he has done a ton of work, and I'm grateful to that he was willing to join us today. He's also the chair of the DIDComm Users Group, which is a group that we run that isn't for writing the spec, but rather for developing things built on top of it. So, very grateful for Daniel. And here's how the plan is: Daniel's going to talk, I'm going to talk. And then we're going to have some open discussion and Q&A. And so you can ask questions in between. We may or may not get to them, but we will get to them at the end. And I'll sort of signal when we're attempting to enter that phase of stuff. And we'd love to hear from you, questions, comments, thoughts, and all of that. So with that, Daniel, the floor is yours.
Let's see how gracefully I can share my screen. My prediction is not super gracefully. Let's see. Okay. Oh, it's not too bad. Okay, so the title that's showing here on the screen is not quite the same as the title that was advertised, because I'm only doing a section of the overall presentation, but hopefully you'll see how it relates. I'm going to focus really on what DIDComm's true value proposition is a little bit, and then I think Sam's going to talk about the implications of that value proposition in the larger internet as we move forward. I'm going to use some slide material that I have talked to before, but I'm going to speak to it a little bit differently. So hopefully nobody will feel bored here. This is a screenshot from the DIDComm spec, DIDComm V2 spec. And what I want you to notice from is
it's not actually on call. No.
The parts that are colored there, the red box and the yellow box. What is DIDComm is the red box, and then this yellow thing is what I want to kind of talk about, that it's the second half of the sentence, the part that's in red, not the first half of the sentence. That's interesting. If you look at the first half of the sentence that I have not highlighted, it talks about secure and private communication. A lot of folks that encounter DIDComm think that secure private communication is its value proposition. And it's true that DIDComm cares about that, but that's table stakes, not its main value proposition. Hopefully I'll convince you of that as I go on here. So let's have a look at a matrix that I built. Those of you who saw me talk about DIDComm misconceptions at IIW saw a matrix a little bit like this, but this has been changed a bit since you may have seen it before. This is comparing different technologies and it's talking about, you know, different features that they might have. The thing I want you to notice here, first of all, this is part of a very large matrix. There's a lot of ways to compare things. But if you look at the columns, you've got DIDComm as a column, you've got web services and TLS as a column, you've got email. These things are not all, they're apples and oranges. They can't be directly compared. The architecture section of this slide deck has, I don't know, 15 lines or something there, where I've mostly compared things directly straight across. But in fact, we all know that email and web services are really fundamentally different in important ways, and they have different use cases. So when we talk about what DIDComm is used for, we sometimes tend to do head-to-head comparisons that hide deeper issues. And I think Sam's going to show why web services and that whole world of open API Swagger stuff that we all know and love, that has become so fundamental to Web 2 and is turning into something important for Web 3 as well. That world is not really a very good analog in some ways to what DIDComm offers, and the two can be used together. So I'm not going to dive into this matrix in great detail, but keep in mind that there's some very interesting information that could be used, and the important thing to know is, what are you comparing? Are they apples or oranges? This is the definition I've used in other places for DIDComm. What I'm going to do is very quickly talk about each of the colored boxes on top of that definition. So if DIDComm is a framework, what do we mean by framework? We don't mean an API, we don't mean an algorithm or a data model or a format, and we don't mean a library or a component. What we mean rather is a structure that is used to enclose or support something else. And the something else is part of why DIDComm exists that makes it unique. It's higher level protocols, which we'll talk about. Safety in this definition is more than just security. It's also more than security plus privacy. Some of the features that we like to talk about in the decentralized identity community, I categorize as safety features, even though they're not often seen that way by a cybersecurity party. So for example, having a form of communication that is resilient, that is censorship resistant, that is owned by no one. These are all, in my opinion, safety features. And safe is an important word for DIDComm. Now this next phrase, structured interactions, is also important. There's lots of ways you can interact. If you talk to your friend over, let's say, a phone call, there's no formal structure to that phone call. You might have a convention that you say hi when you pick up and bye when you hang up. But other than that, you can say whatever you want. You can have long periods of silence. You can turn your camera on. You can play cat videos. You can do whatever you want. There's no structure to the phone call. And that same kind of characteristic is true of many other ways that we interact. On Slack, there's a little bit of structure, but it's not a structure that you could map onto, for example, the process of applying for a loan or the process of giving formal feedback or testimony in court or all these other things. Those are highly structured interactions, and DIDComm cares about structured interactions. It doesn't only support the unstructured variety. And lastly, built atop DIDs. We all know why DIDs are important and interesting. But there are some possible analogs to DIDComm in worlds that aren't DID oriented, and that is interesting. Now, many of you may be familiar with work that's going on at the Trust Over IP Foundation, where they like to use this particular diagram. And I wanted to show you how DIDComm relates to that diagram in case you already know this, have this mental model. In the Trust Over IP thinking, there's a 4-layer stack, and the bottom of the stack is what they call public utilities. This is essentially blockchains, cryptographic primitives of various kinds, signing technologies. And then above that is what they call peer-to-peer communication. That is the heart of DIDComm messaging. Or another way to say it is DIDComm messaging focuses on that problem domain. And then above that, there is what they call layer 3, trust task protocols. These are formal structured interactions that accomplish some kind of a task that either builds or consumes trust. For example, issuing credentials, proving things with credentials, applying for a loan, as I said before, making a payment with some kind of digital money, lots of others. So DIDComm exists both to provide the primitives of peer-to-peer communication and to make it easier to construct arbitrary trust task protocols or application level protocols atop those primitives, and to combine those protocols into ever more complex workflows. This is another view of that same stack, and you see the DIDComm logo there on layer 2. Some other technologies could be brought into layer 2, for example, notably Carry, but there could be some other ones as well. But whatever is at layer 2 is what you might call a thin waist in a new world where the internet trust problem is fixed. And it's a thin waist in the sense that many things could be built above it that depend upon it. And underneath it, there are many dependencies. But it by itself is a very, a very carefully constrained small set of features. All right, almost done. So what does DIDComm tell you how to do? This is a long list. I'm not going to read it all. But suffice it to say that DIDComm answers a whole bunch of questions in a standard way. And these are all questions that turn out to be important if you care about trust and you care about decentralization and you care about composition of higher level protocols. There are a bunch of questions that DIDComm doesn't answer, and sometimes in the community, people have thought that DIDComm was tackling one or more of these questions and been surprised when we said, no, that's actually not a DIDComm concern. So here are some examples of higher level protocols that you could build with DIDComm primitives. Hopefully some of these protocols look quite interesting to you. Others might be something that you think nobody wants, or you might say you'd never thought of that before. The big thing I want you to get out of this list is it's a lot longer than the first two. We tend to talk about issuing credentials and proving things with credentials as like the whole use case of SSI. And in fact, there's lots and lots of use cases. You want to run a MOOC with 10,000 students across the internet and test them, you might need some trust protocols. Okay, what's it like to use DIDComm? Here's a little sample code from Alice and Bob, if Alice wants to send Bob a message. The details are uninteresting, but the thing that you need to know here is that's about how much code it takes to send a secure message with DIDComm. Not very much. DIDComm's built on some standards, many of which derive from thinking that was published by NIST, and many of which are part of the Jose family of specs. We won't go into the details. Some things that DIDComm might be comparable to, I'll let you look at that list for just a second. These are analogs. No analog is perfect, but you can see some things that suggest ways that DIDComm is interesting or not. And then lastly, this diagram, if you compare the world of APIs and the world of DIDComm messaging, you find that just like there's this thing called Open API, aka Swagger, that you use to build individual APIs atop. There's this thing called DIDComm messaging, and you build individual APIs atop that. But in a kind of a casual conversation, you might describe everything from Open API and above as the world of Swagger, and everything from DIDComm messaging and above as the world of DIDComm. One of the key issues related to DIDComm is whether parties are clients or servers or peers. And this is something that I think Sam's going to riff on a little bit, so we won't go into it deeply on this slide, but suffice it to say that most of the web as we know it today is very client server oriented. That has certain benefits, but it also has some important disadvantages that I don't think the world has fully understood. And the future of the internet, as Helen promised in the title of this webinar, I think is tied with understanding when we're making a trade-off that we don't want to make by locking ourselves into client server architectures. Sam, I'm going to skip over these and give the microphone to you, but maybe we can refer back to them if anybody's got some questions. There's some information in this slide deck about implementations, and if you go back to the recording on these of this webinar at the very beginning, there's a link to the slides. So if you want to find this information, go to the first slide that I showed, look up the link, and then page forward to get to this, and you can go find the links. But suffice it to say, DIDComm is available in many different languages, and it's easy to use. And if you want more information, here's some links about it. So I've talked quickly. I promised Sam I wouldn't take too long. Sam, should I hand the microphone to you? Do you want me to keep sharing or stop sharing and you share your own way?
Why don't I share?
Okay.
Daniel, that was awesome, by the way.
Sorry for the fire hose.
It is good. That's why we record this. We can go back and watch it later, slower if necessary. Really good. And I was going to say this, but we will share the slides because obviously the information slides are more useful if you can actually use the links. So very good. So the end part that Daniel skipped over a little bit, I might go use some of his slides because he is a better slide artist than I am. That will become very obvious in a minute if you don't know already. But there's some really important concepts that will help you understand DIDComm in an important way. So you got a lot from Daniel now, and we will. And I want to go back a little bit to some fundamentals. It's hard to argue against two technologies on the internet and the impact that it's had in a really huge way. And the two things that I'm going to argue here are email and APIs. Email was first. It was one of the first technologies that the internet actually had, and shaped a heck of a lot of the internet, and notably has some interesting attributes. APIs are also powerful and have enabled types of system integration that just simply wasn't plausible before. That have also improved technology substantially. So let's talk about it. Email is unique in that, it wasn't unique at the time. This was kind of how everything was built, but the parties interacting over email are peers that have identical capabilities. I might be a person and I might be emailing a company, but we both have the same capabilities with email. We can both attach them. We can set attachments with them. We can send to any other email address. There are servers in the middle that I've represented with these gray boxes, but they're uninvolved in the sense that they don't actually do much to the email. They route it, and there's some headers that they append as part of the mechanisms in that protocol. but they don't actually do anything. They don't translate its language really, or manipulate anything. There's often like virus scanning or something involved, but it's relatively uninvolved. There's also no semantics. It was interesting when Daniel brought up the slide with SMIME, because it was designed to allow for some semantic information to be sent. And we have that in use today. We can send a PDF or a spreadsheet or a text file or whatever we want as an attachment to email, and that works. But we didn't get to the point where we really have structured communication over email. And so that's one of the downfalls that it actually has. It also doesn't have a lot of security by default. You can encrypt stuff that you send over it, but email was created in an era when most of the people that ran nodes on the internet actually knew each other, and so there weren't that many security concerns in the beginning, and as a result, everything's been an attack on. So now let's look at APIs. APIs are great for semantic interaction. The API is defined. We know what things we send to the API. We know we have expectations about what's done when we call an API. Authentication and encryption is standard. That's a normal thing you do to allow, prove that you should have access to the API and that the information you send to the API is encrypted or get back from it. Servers and clients are important here. Daniel talked about the difference between a client server and a peer. And in a client server architecture, it is fundamentally unbalanced. One party is in control, that's the party that hosts the API, and the other party simply must abide the control or leave or refuse to participate. And that's not a great power balance, as opposed to something that is more peer-based, where the power is shared and distributed evenly between the parties involved. It also is important because if you want to be in charge of this interaction, you have to have an API. You have to have that infrastructure. So you'll notice that I've used a little server symbol here and a server symbol here. And one of the things that APIs are best at is actually interactions between systems where they are both capable of hosting an API, and they can interact back and forth between themselves. I have to mention webhooks here as a simplified return API, and there's been lots of good stuff there, but webhooks have their limitations, specifically that you still have to have infrastructure that you are hosting or paying for in order to be involved, and that's a problem. I'm going to go back a couple slides here because Daniel drew some pictures here that I think are really valuable. This is designed as a demonstration of APIs. You'll notice that the shapes here at the top of what he's drawn are intentionally significant. The shape indicating what can plug and what can't plug. If you develop a client for a specific API, then it can work with that API, but doesn't really work with other APIs out of the box. It doesn't natively work that way. And here's the types of things that are provided by APIs typically that are part of the shape of that interaction. I will mention that there have been attempts to standardize APIs in a way that goes beyond a single instance, and one of the most notable is WordPress. WordPress is a blogging platform, has an API, and there's lots of different instances of WordPress out there that all share the same API. And there was hope early in the days of APIs that there would be more of that, but it has turned out to still be shockingly rare in a really unfortunate way. Having more common and standard APIs around companies would allow for clients to be able to plug into more properties than just the ones that they were intentionally or specifically designed for. So here's a similar picture, but that describes DIDComm in an important way. And I have a slide that I'll get back to it in my slides, but you'll notice that the shape of the top and the bottom of each of these parties is actually the same. And this implies that not only can this peer connect with this peer and all the others, but of course these peers can play the same role and interact with all the other parties here. And here's some similar properties that DIDComm provides. One really useful one is discovery here, is the ability to communicate between parties about what types of features you actually support. And this allows for some auto configuration and for some auto discovery to happen between peers. So because not all peers should be or can be the same. If your peer is a light bulb, it might be able to turn on and off. If your peer is a person, you might be able to call them on a phone, but you can't turn the person on and off, and you can't call the light bulb. And so understanding that there's different capabilities that each of these peers have, but a unified way of accessing them is a very important way of doing this. One thing that's not represented here is a really powerful of DIDComm, and it impacts the way messages flow between parties. So I'm going to jump back here to the similar diagrams that I've been using. So if you think about about DIDComm sharing some of the attributes of email and some of the attributes of APIs, we end up with a really nice combination of the two. So among other things, we get semantic interaction, something that we never got to with email. And so the messages have schemas. There are specific purpose. There's expectations about what you do or what the information means when it's transferred between parties. Authentication and encryption are standard. That's just kind of included. You don't really have to think about that. The spec already includes that, and you don't have to. You have to invent something yourself, which is very nice. But you also end up with, and this is the really important bit, peers with identical capabilities. Any person who can send or receive a DIDComm message has the same capabilities within DIDComm as any other party that can send or receive a message. There is also, you'll notice the return of these gray boxes here in the middle. There are also some uninvolved infrastructure in the middle that helps this. And you're going to find this anytime you have a message-oriented architecture that does not require high availability of a message destination. And that's important, because DIDComm actually excels at interacting with people-oriented devices. And what I mean by that is things like phones or tablets or computers that are typically not on all the time, nor connected to the same internet, or certainly not highly available in the server sense of the word that would be required to host something like an API. And that balance, the fact that everyone is a peer here, is really powerful. So DIDComm combines the best, I believe, of email with the best of APIs in a really powerful way. Do I think that DIDComm is going to immediately kill either one of them? No, probably not. And I'll get to a Venn diagram in a second. The main point that I'm hoping to convince you of here is that DIDComm picks up where email and APIs leave off. They have limitations and they have things they don't do well. And DIDComm picks right up in those areas and can support a manner of interaction that is very powerful. And semantic peer-to-peer interaction, Daniel had that really cool slide of potential protocols, for example. Those are all semantic peer interactions that could occur in a really trivial way. One of the things that an example of a semantic peer interaction that I would really like is that I'd like to be able to ask a business that I frequent when their hours are today. Not generally on a Tuesday, but today, this Tuesday, because this Tuesday might happen to be Christmas Eve, or it might happen to be another holiday, or there may have happened to be a power outage all day yesterday, and they're not capable of being open today. And it's different asking what your hours are on a Tuesday and what your hours are today. And that's the type of interaction that I think would be really useful, and that I could engage software to help me manage my life in a really useful way. I've already talked about people-oriented devices, but I also want to talk about IoT devices. IoT architecture right now is very API-centric. It's hard for an IoT device to host an API because it requires more computing power and a more high availability than it typically has. And this is often because IoT devices are battery powered, which means that they sleep for long periods of time and wake up briefly to sort of check in with the universe and then turn off again. And so DIDComm, as a message-oriented architecture, allows for IoT devices to be peers in the sending, but also the receiving of DIDComm messages, according to whatever protocols they support. And this would allow, rather than buying an IoT device that then connects itself via some API in the cloud, and then I have a mobile app or some other limited interaction with it, I am capable of having an IoT device that talks over my local network using message-based or other transports using a secure message system that allows for bidirectional communication. And that would change the nature of the IoT devices and how they're designed and how they're built today in a way that would make us all happy, including when we buy a device from a company that ends up vanishing and suddenly the thing becomes a brick. And so there's a huge amount of application here. So this naturally begs, where should email and APIs actually live off? And I'm not going to pick on email, but I am going to pick on APIs here. APIs actually, I think, are really useful at server-to-server interaction. There, you could argue the zero trust architecture that DIDComm could provide in such a scenario by having the messages themselves encrypted, and rather than relying on things like a fixed key between two servers. But by and large, server-to-server interaction is well covered by APIs, and I'm not really proposing that we run out and replace everything immediately. What DIDComm does do really, really well, that APIs also kind of are currently doing, are the people-oriented APIs. And what I mean by this is that if you have an API that interacts with a consumer device or an application that a consumer uses, then that is subject to review and maybe better served by a DIDComm protocol rather than a traditional REST API, among other things, in the fact that it lets you be bidirectional in nature, rather than only having the software that the user is using call into you. You can actively push intelligent messages out to it. It not only results in more efficient infrastructure, but it allows for a deeper, more semantic interaction with folks. You'll notice that a lot of folks, the primary communication with companies is email, and they'll often just block folks or refuse to give them permission to send them email, and if they're behaving, they won't, because there's not really a way to tell the difference between a shipping notification, trivially or semantically, and a new offer where they're trying to push some other product that you may or may not be interested in. And the semantic nature of DIDComm allows for there to be differences in those kinds of interactions, which means that when I create a relationship with my grocery store, I can allow them to send me receipts for my purchases and a record of what I did, but not really allow them to send me tons of offers all the time about new things that they have on sale. And so these are the types of things that are currently served by APIs that need to be considered for DIDComm protocols. The clear winner here is people-oriented devices and IoT for the reasons that I've already mentioned. Those are really important reasons, or important things where APIs leave off. They are not capable of well serving these things. And so DIDComm shows up in a really nice way with the capabilities to interact between these devices in a really powerful and useful way. So this is, I'm less artistic than Daniel is in his slide creation. I'm grateful to lean on some of his diagrams. But this is what I hope to help you understand, is that DIDComm is adding capabilities to the internet that it doesn't currently have or is well provided for by other existing technologies. So here's the Q&A portion. I know that Daniel's been doing an awesome job answering questions in the chat, which is great. So if we have new capabilities that haven't existed really well on the internet before, what does this mean for the future of the internet? And so Daniel's been actively answering questions, which is really fun in the chat. Daniel, are there any you wish to highlight as interesting questions, or does anyone want to ask a question in our discussion here? We made sure to leave some time.
Well, there's one that I just answered and one that I was about to answer that maybe I could talk about. Vinay asked a question. I'd like to kind of repeat it, even though my answer is already in black and white for everyone. But he said, well, what about something like WebRTC? Isn't that providing a fairly similar kind of a feature set? And the answer is yes, in the narrow sense that if you live within the boundaries of the ecosystem of a given WebRTC channel, and you never plan to leave that ecosystem, then you have a fairly similar kind of security profile and so forth. But WebRTC, takes the foundations of its security down to a different direction than DIDs, and there's an interesting consequence of that, because the foundation of the security is not something that's portable into another context. Like a DID, I could talk to you about my DID or sign messages using keys associated with my DID on email. I could do it on chat. I could do it on lots of different channels. But WebRTC is an example. very similar to many other technologies where the security is captive to the channel. If you try to take your security that you built with Signal between you and your friend, and suddenly you say, hey, let's continue this conversation over email, it doesn't work. You have to start over and re-authenticate the other person, because the basis of security in email and the basis of security in Signal are different. And then the other thing that I didn't say to Vinay, but I'd like to also call out is secure real-time communication sounds very broad, but it typically encompasses only unstructured communication. That is, you can carry on voice over IP calls, you can send SMS messages, you can send text, whatever, but you can't apply for college because there is no defined recipe for applying for college over WebRTC. You could build such a thing, but every new protocol you tried to build on top of that would be an entirely new project starting over from first principles. And this is actually one of the problems that DIDComm also tried to solve, is whether you're playing chess or taking a test in an online class or presenting credentials, let's make the fundamentals of the interaction the same so that we can combine them. I can start by playing a chess game, and halfway through, when the professional chess player on the other side says, this isn't worth my time unless you pay me, I can then engage in a payment protocol. It's a seamless experience to flip from one kind of interaction to another because the context is portable across all of them.
So one thing that I'll add to that is that we did a session here in the Indicio Community Meetups that I believe is recorded and probably on YouTube, where we talked with the folks at Hero, and they actually combined the use of DIDComm and WebRTC. So they bootstrap a WebRTC connection from a DIDComm relationship, and that allows the transitive trust that existed in the DIDComm relationship, including any previous conversations or credentials exchanged or any other data, to be transitive to the WebRTC connection for the particular purpose of that more high bandwidth interaction. YouTube is a messaging oriented architecture at this point, which means that it has no facilities for like high bandwidth data streaming. But by bootstrapping that from DIDComm, there's some really cool properties that you gain from doing so. So really good answer. And Helen, I think, has the link in the chat for that meetup, which is good. Me Novak, your hand is up.
Yes, thank you very much, gentlemen. This is fantastic. So my question, you piqued my interest when you brought up some of the app level protocols. You mentioned 3, and I'll let you choose all 3 or just one because of time. The check biometric, rich chat, and ask Alexa. And I'm working currently in the conversational voice AI world and in the metaverse. And I look at voice as the means of communication, no surprise. But then it comes to, how do I know that's really Sam talking to me? And my current premise is, well, perhaps I could use a VC or DIDComm to authenticate and authorize. But I'm curious to hear more what you have to say about those 3 protocols: the check biometric, rich chat, and ask Alexa. Thank you.
Good question. Daniel, I'm going to mention something just briefly and then turn over to you for more discussion. DIDComm itself uses something called authenticated encryption. What that means is that when you receive a message, you can be sure cryptographically that the sender of the message is in fact who you think it is. So it both authenticates and encrypts the message at the same time. It's a good way of thinking about it. What it does not do, what DIDComm itself does not do at the core level, is assure you of who is the owner of that particular DID. And so you mentioned verifiable credentials, and that's the typical way that we talk about gaining trust or confidence in the ownership of that particular DID. And so I wanted to highlight that as something that very specific that DIDComm does, and then of course other things that you could build on top of it to go further. And with that clarification, Daniel, what are your thoughts?
Let me answer by proposing a futuristic scenario that's DIDComm oriented underneath. So let's suppose that a particular person is walking around the house doing various tasks, but having a conversation with Alexa as they, tie their shoes and get ready to go out to exercise. And they say, "Hey, Alexa, are there any Tai Chi classes near me?" And Alexa says, "Yeah, there's a Tai Chi class, that's Saturdays at noon." "Oh, perfect," says the person. "Please enroll me, Alexa." And Alexa says, "Well, it seems that this class will require you to commit to come for at least 6 weeks. They don't want anybody to show up and not take it seriously. Are you willing to make this commitment?" You say yes. And Alexa says, "Are you willing to pay for it?" And you say yes. And Alexa says, "Which credit card do you want to use?" And you tell Alexa. And then Alexa comes back and says, "Oh, by the way, there's some celebrities in this class, and they want everybody to, agree that you're not. What happens in the class stays in the class. You're not going to go out and tell all the paparazzi how awkward they look as they do their Tai Chi." I'm making this up as I go, but here's the point. As you're having this conversation with Alexa, you're crossing task problem domain boundaries. Paying for something is one problem domain. Looking up and scheduling something is another problem domain. And then if Alexa says, "Great, I want you to agree to sign the NDA that goes with this celebrity Tai Chi class," Alexa says, "Can I record your voice and run it through a biometric thing so that I know I'm really talking to you and not your daughter who is crazy about New Kids on the Block?" I know that's a dated reference, but anyway, so Alexa has now challenged you for payment, challenged you for biometric proof, and done a number of interactions, and all of those can be knit together into a seamless flow because all of them are based on DIDs that you control, and you can be held accountable for the part of the interaction that had legal teeth to it, and for the part that had payment, and held accountable in different ways. That's the beauty of this. If we were doing an API-based world, you couldn't really do it. And if I made it even harder and said, "I want to do it just like I described, except instead of talking to Alexa, I want Iron Man's," what was the name of his device?
Jarvis.
AI. Yeah, Jarvis. I want Iron Man's Jarvis because I don't want to talk to a service run by somebody else. I want to talk to my own service. And even if the internet's down, I want it to work. Only DIDComm could let you do that. Because today, every other incarnation of this kind of technology requires you to ship all of this information across the internet.
Yes, absolutely. Thank you very much, Daniel. That was great. I'll follow up with you later, but that was good. Thank you very much.
Daniel, you offered 3 options, and Daniel picked the hardest of the 3 to enumerate on, which is awesome. So in the chat, can you kindly expand on the Book Hotel application protocol? I want to highlight that with the exception of issue credential, prove with credential, which we call we have that, but it's not called prove with credential. And also rich chat, there's some work going on. None of these other ones actually exist yet. This is postulations on what protocols could actually exist. So when we talk about one of these protocols, like the Book Hotel protocol, we're spitballing, we're making it up about what it might actually be. But that's relatively important. But I'll take a minute and attempt to do a similar thing to what Daniel just did here, and highlighting some important bits. When you let's say I'm on a road trip, and I didn't book a hotel because I didn't know how far I was going to get. If I have a software agent, and I hope to, Mike, to answer your question here about what another interaction looks like that isn't credential based specifically. If I have an application on my phone that is aware of DIDComm, by the way, we think right now of DIDComm as things that wallets implement. And while that's true, because there's cryptography involved, we wouldn't think weird things about an app that uses APIs, right? Because like all apps use APIs. And so thinking that all apps are going to end up using DIDComm, or at least certain ones in the range would use DIDComm, and we wouldn't think about them differently because they did, is probably the right way to think about this in the future. We're still at the wallet phase right now, but as this expands, then it will get there. So let's say we have a hypothetical world where I have an app that's capable of talking to my navigation software that's running in my car on my phone, and it knows where I'm going. It also knows what time it is. It knows how long I've been driving, and it could use that information along with where I'm going to automatically look for and start a negotiation with hotels. Hey, if I want to stay there, I need a room of this size, of this number of beds. How much is that going to cost? And my agent can do that. Of course, I've given it permission to like actively search out hotel deals when I'm on a road trip. This is not without my permission, but it's able to look ahead and suggest stays at those particular hotels. Now, it might have gone through something like Priceline, but even better I like is an architecture that allows me to discover the hotels and actually communicate with them directly. And so that hotel is capable of negotiating with an inbound traveler for a room stay for that night or the next night or whatever's appropriate in a very direct manner. And so that book hotel protocol might be actually a collection of protocols that actually work together. There's no reason why you have to put everything together in one protocol. And a good example is negotiate price and payment method. Is that in the middle of booking a hotel, part of that conversation is going to be about what rooms are available. Part of it's going to be about what it costs and what it costs based on how much I'm paying. Is it cheaper if I pay in cash? Do you accept checks? Is there, what credit cards do you support, or can you take Bitcoin, right? And so those are the conversations that can happen. But the price and payment method is actually relatively common amongst all sorts of stuff, not just hotels, which means that my software might be beginning that protocol with the hotels down the road, that it can suggest them to me. If I decide that I don't want them or I ignore it, then it can, as a courtesy, mention to those parties that hey, we're not interested anymore, but thanks. And if I decide to, hey, that sounds really great, I can click on one, perhaps in an interface, and then it could complete that hotel booking for me, providing the necessary information to make that happen. As part of that interaction, so none of that was really credential based, but as part of that interaction, there are some places where credentials actually show up. I may want to know that if they claim to be a AAA rated hotel, I may want proof that they're a AAA rated hotel. And so I can ask them for that and they can provide that. Similarly, they may want to know that that I'm a trustworthy person to come to them. And so they could request credentials from me that indicate that I'm not good for payment and that I leave rooms in good order, et cetera, that I have received from perhaps other hotels with previous stays. We can get into reputation is a really interesting topic we can get into another time, but those are the types of things that VCs would enable. But VCs are not necessarily baked into or they don't own the entire process. For example, when I ask for a reservation or ask for availability, I don't have to craft some VC request. They don't have to give me that as a credential. That's way too commitment heavy for the question I'm asking. And then when we actually finally get down to sort of the brass tacks of the things, that's how it actually puts that together. And because of that combination of protocols that DIDComm allows you to stitch together, it means that you're very likely to have the capabilities to communicate between two different parties that support a variety of different protocols as part of that process. So that app that helped me book the protocol may or may not be my wallet as we think about it today. But it is certainly aware and probably communicates with software that I have that enables that. For example, for the presentation of credentials, but may not only or solely be integrated with that in the same way. And so hopefully I would try to 2-for-1 that both from the hotel question and from Mike's question about what an application might actually look like in that manner. So this has been really interesting. We still have time. Daniel, anything that you want to surface? Oh, Colton's got his hand up. Let's go to Colton first.
Yeah, one of the things that Daniel had touched on a bit, which I think is huge, is the ability to go ahead and communicate offline without having a server in the middle, or without internet. Because if we take a look at events within the past 10 to 20 years, there was an instance where Egypt, I believe, had cut off pretty much all of their citizens off from the internet, and where in today's society, we're putting more and more money. We're not having cash on hand. We're doing everything more digital. And that places you in a situation where if your government, for whatever reason, decides to cut you off from the internet, does that mean your debit card, your Visa card, your like PayPal is going to continue working, or is it not going to work at all? Like, can you even buy simple necessities like groceries? And being able to communicate device to device is huge, because then it just prevents those situations from putting the citizens at risk of basic survival.
So really good.
Can I
You
react
hit.
to
Let me.
that real quick?
Yeah, please, Daniel.
I just spent a year building a DIDComm V2 protocol for digital cash. And one of the design criteria is exactly the thing that Colton is talking about. If you are a country, and digital cash is not cryptocurrency, this is like a country's monetary system, the US dollar, the euro, the Swiss franc being converted to a digital form. One of the considerations you have as a country is we can't allow some hostile nation state to take down our monetary system. And in fact, we see countries in the world right now that are at war where clearly another country might try to do that. So this is not an academic thing, and it comes into play all the time. And I thought when I started this, oh yeah, there's these interesting corner cases where offline matters. But here I am living in Switzerland that's highly connected and has great infrastructure. And yet every day on the way to work, I have a specific part of my train ride where I pass through tunnel and lose an internet connection. And so it's actually more ubiquitous than we think. And it is, I agree, it's a really important feature.
So it goes beyond just disaster prevention. There's some efficiency things that come from it too. Other examples where the network may not be behaving very well is in an airport while you're trying to go through a customs line, or perhaps at the entrance gate to a music festival, right? Where the sudden appearance of thousands and thousands of connected devices overwhelm the towers, and it makes that very slow. Even if it would work, the ability to actually transfer something over a transport like Bluetooth is valuable. I'll highlight that the way DIDComm is designed, the trust in the message doesn't come from the transport, but in the message itself, which means that you can, that if Daniel, for example, let's say, he's in Switzerland, I'm here, we're obviously exchanging things over the internet because Bluetooth doesn't reach that far. Let's say we both end up at the same conference. We would then be capable of exchanging messages over Bluetooth directly device to device, within a couple of feet, with the same trust properties that we used when we actually had the message travel across the internet. And that's a very valuable case for all sorts of interactions. And it can actually change the way we think about the internet. Right now, a connection has to kind of go through the internet for it to really be on the internet, right? But when we think about the internet as a largely connected device, I think you could argue, at least in the abstract sense, that if Daniel and I can talk over the internet, but are also happen to be feet from each other and are passing data directly, we are still participating in the broad scale or broad concept of an internet, despite the fact that the packets that we're sending don't travel through any main routers. And I think that that's an important architectural aspect of what we're talking about here, is that this allows for connection in a really, really useful way that both works at scale on the internet, with when you're not proximate, and it can also work closely with other folks. You need a way to access the verifiable data registry and other information unless you already have it. A conversation we don't really have time to go into today is machine readable governance frameworks and how the decentralized ecosystem governance can allow you to know in advance the types of things that you might want to have cached, so that you have a cached copy of the necessary information from the VDR. And that means that you don't necessarily have to have live access to it in order to confirm those facts and details. And we have use cases that have been doing things along that way. So we are about out of time. The conversation has been fantastic. If you are interested, please reach out and join one of the community groups that Daniel put in the slides, or or reach out to us individually. We would love to continue conversations. Daniel, we have just a minute left. You've been a very gracious speaker here with us. Is there anything that you would like to mention or to draw attention to that either you're working on or that you think is interesting for the crowd that we have here?
Well, I'll mention that the rich chat thing, there's some active work going on to essentially create something approximately like, you know, a Slack or a Discord, but based on DIDComm. There is a DIDComm user group, and I'd really love to have people come to that. It uses a unique meeting methodology called an unsync, where basically we have a 12-hour block once every 2 weeks, and you're supposed to pick some portion of that 12-hour block to allocate to the meeting, and you can allocate 10 minutes or you can allocate an hour, but there will be a published agenda and several chat threads that start up during that 12-hour block, and things will get discussed and decided, but you don't actually have to appear in person to interact. So it's async, but a little bit more formal than normal async because you have a scheduled time that you're supposed to come. It's just that it's a time you chose, not a time somebody else chose. And there's a link to that user group in the slide deck.
So you can't even blame a meeting conflict on not being able to attend and participate. So appreciate that. Thank you, Daniel. We're grateful for everyone that came, and I hope this was a useful conversation. Thank you for Helen for organizing, and we hope to see you again.
Thank you all. I'm going to put some links in the chat as well to some different events and helpful links. Coming up is the Aries Interop event, which is happening tomorrow in the Hyperledger Aries community. There's a Hyperledger Global Forum that's happening in Dublin. There's also a remote option for that particular event, and you can find that information in that link. And IIW, I think I saw Phil here, so I wanted to mention IIW is coming up in November, and a lot of these conversations happen there. And then I included a link to the different community groups that Indicio is involved in and where we draw our inspiration for these events from the conversations that are happening in those community groups. DIF was mentioned today. Hyperledger was mentioned today, TOIP was mentioned today, Aries was mentioned today, the whole works. So if you're looking for kind of a rundown, a list of when those meetings happen, some of the a collection of those meetings happen, you can check out that link. Yeah, thank you, Phil, for dropping that link in again. Yep, see you all at IAW for sure. And again, this happens every month, this particular meetup. We will be doing another meetup at the end of September. The last Tuesday in September is where we kind of try to aim for it, last Tuesday of the month. We will be having a conversation, I believe it's going to be around FIDO and decentralized identity and sort of how they complement one another, and we'll have some interesting guests. If you have something that you want to talk about, if there's something in the community that pops up, piques your interest, please reach out to me, use the meetup. I'm Helen at Indicio, so please feel free to drop me a note. If you have a particular topic you want to talk about, you want to present something, you want to get a panel together, I'm happy to help support all of those efforts. So thank you again today. Thank you for Indicio. Again, I'm so happy to have the opportunity as a public benefit to support these types of conversations. And we will be sending out the recordings and links to the deck once the Zoom cloud world tells me that I can do that. So it should be shortly. So thank you again for everybody for joining us today. And we are really happy to see you all here. Hopefully someday in the future, we'll do something in person. So keep an eye out for that. Thank you all for your time today.